So here we have a compound, and at the center of the compound, this carbon right here, we have a chiral center. And let's remember, a chiral center is something attached to 4 unique substituents. So on this carbon we have this amine group, and then we have a methyl group, an ethyl group, and a hydrogen group, and that's not drawn in right now. But when molecules have chiral centers, we can give it something called an absolute configuration, and we do that with the Cahn-Ingold-Prelog rules, which basically just say atoms that have a greater atomic number get higher priority than ones that have lower. So go ahead and pause the video and see if you can determine the absolute configuration of our compound. So here, our nitrogen weighs more than our carbon, so this is going to be number 1. Our ethyl group has 2 carbons, so we're going to give it number 2. And our methyl group has 3 carbons, and don't forget we have a hydrogen as well, and the hydrogen is going out of the plane. And that's exactly how we want it when we're assigning absolute configuration. We want the hydrogen, or the lowest priority substituent, moving away from us in the plane. So if we look at this molecule, the blue here is our nitrogen. So our nitrogen is right here, and our hydrogen is moving away from us in the plane, just like that. So we now connect the numbers, and this is going to go to the right, clockwise. Whenever it's clockwise, we have our configuration. So let's go ahead and look at another one. So here we have a cyclohexane molecule, and we can't really say that this is a chiral center here since we don't know what the R group is, but over here we can. So we have a carbon here, more carbons attached, a methyl group here, and a hydrogen, of course. So we're going to go ahead and assign our priorities. This is going to be number 1. Our number 2 will be right here, 3 right here, and let's draw in our hydrogen right here. So same thing, we will connect our dots, and we have another clockwise rotation. So we would say that it is R, but that is actually incorrect because our hydrogen is coming towards us in the plane. So we will have to invert our answer, and it will be S. So a good way to understand this is we always want our lowest priority substituent, which is hydrogen in this case, to be moving away from us in the plane, like this molecule here. The hydrogen is moving away from us, and our nitrogen here is moving towards us. So in order to do this, currently we are looking at the molecule like this. We're looking at the molecule from this angle. However, we want to get behind the molecule and look at it like this, from behind the molecule, so that our hydrogen is coming towards us in the plane. So if we were to be standing behind the molecule and draw a new thing, I would draw like this, and it would be S.